Members of art club are between 14 and 17. The graph shows the number of students of each age in the club. What is the total number of students? Okay, well, looks to me like 14, there's 1, 16, there's 3, and 17, there's 2. So 1 plus 3 plus 2, which is 6. Determine the average age of the members in the art club. So 1 times 14 plus 3 times 16 plus 2 times 17 divided by 6. And that, I believe, 14 plus 48 plus 34, 96 over 6, and that will be 16. Determine the number of 15-year-old students that must join the art club so that the mean age of all students is exactly 15.5. So we already have 96, and then we're going to add a certain number of 15-year-olds, and then we have to divide by the total, which would be 6 plus x, where x represents the number of students who are 15. And they're saying that is equal to 15.5. So we have a little bit of algebra here. 96 plus 15x, 6 times 15.5, which I believe is 93, plus 15.5x. So we will have 0.5x and 3, and then when you divide through, you get x is 6. So you need to add 6 students who are 15 years of age in order for the overall average to be 15.5. In a magic square, the numbers in each of the 3 rows, each of the 3 columns, and each of the 2 diagonals have the same sum. The sum is called a magic constant. Each of the 4 figures shown below is a magic square. In figure 1, the magic constant is 18. What is the value of n? All right, well, let's take it one step at a time. Let's see what we get. So where do I want to start here? Let's start with here. Let's put a little x there. 7 plus 2 plus x is 18, because they gave me the magic constant. So that basically means that x would be equal to 9. So put 9 in there. And then now let's work with the diagonal. 9 plus n plus 3 is 18, so that means n would be 6. So that solves the first one. Figure 2. What is the value of p? Okay, so same kind of story. You just have to kind of fiddle around with this, see what we get. So where do I want to start here? Well, 8 plus 9 plus 4, that would give me the magic constant, right? So that's probably a good place to start. Let's see here. 8 plus 9 plus 4 is 21. So the magic constant is 21. Okay, so let's work with that. Where do you want to go next here? Well, let's put a little x there. 9 plus x plus 5 is 21. So that's going to be, x is going to be 7. Yeah. Okay, that's pretty good. And then where do we want to go next here? Put a little y here, I guess. And then that would mean that y plus 7 plus 4 is 21. And therefore, that's going to be 11. So y would be 10. Okay, I still haven't found p yet. Where do I go next? I guess that just that top row. So 8 plus p plus 10 is 21. So it looks to me like p is 3. So finally we got p. Okay, moving right along. Next one, figure 3. What is the value of r? Okay, so here we have a slightly, probably going to need a little bit more space. Hopefully I can do it in that. Okay, so same kind of story. We have to fiddle around with this. Where do we start here? I'm going to start over here. Let me just call that y. Actually, let me think about this for a second. Where should I go? Well, I have the last column, r plus 17 plus r plus 3. And do I have anything else? Oh, actually, let me just figure out what that is. That is 2r plus 20. So that's the magic constant, even though I don't know the value of r. And then I can kind of work from there. Yeah, I think that's sort of the whole point. So then I can use the first column, which is 13 plus 7 plus y, and that's 2r plus 20. So that looks like y is 2r. Okay, so that's pretty good. 2r, put that 2r in there. And then where do I go from here? I guess I'll just use this bottom row. So that would be 2r plus r plus 1 plus r plus 3. And that's going to be 2r plus 20, our magic constant. And let's see if this algebra helps me. It'll be 2r plus 4 is 20. 2r is 16. And r is 8. There we go. So we got that. And then finally we have determine the value of u and over here. So I guess the same kind of story. So let's see here. Okay, where do I want to begin here? Let's just figure out the magic constant first. So that will be u plus 2 plus u minus 5 plus u. That's the bottom row there. That looks to me like 3u minus 3. Okay, that's pretty good. And then what's next here? Where do we want to go? Let's call that x. Let's call this y. Yeah. Okay, so the next one... Let's go with the second column there, that one. So u plus 3 plus y plus u minus 5 would be this 3u minus 3. So that would mean that we have y plus 2u minus 2 is 3u minus 3. Therefore, y would be u minus 1. Okay, let's put that in there, u minus 1. And then I guess I turn my attention to the diagonal. So that's going to be x plus u minus 1 plus u plus 2. And that's going to be 3u minus 3. Okay. So that's going to be x plus 2u plus 1 equals 3u minus 3. So that means x would be 2u minus 4. Hold on. Let me just see if I did that right. X plus u minus 1 plus u plus 2, and then 3u. Yeah. I think I did it right, but I didn't get anything. Let me just... 2u plus 1. I didn't get anything because I got two variables, but if I make a different equation, I think I should be able to get this. The first is the diagonal, which is x plus u minus 1 plus u plus 2. And the other one would be that column, x plus 12 plus u. That way what happens is the x's cancel. And then I get 2u plus 1 is equal to 12 plus u. And that would give me u is equal to 11. Yeah, that's what they wanted, right? They wanted the value of u. Okay, so there we go. We got it. Point A has coordinates 10, 5, and C has coordinates 20, 27. Rectangle ABCD has side AD parallel to y-axis and side AB parallel to x-axis. What is the area of ABCD? All right, so let's see. So we've got some rectangle here, and let's just draw it in. So we've got A, B, C, D. So A is 10, 15, so this is 10, and this is 15. Not drawn to scale, obviously. And C is 20, 27, so that's 20, and that's 27. Definitely not drawn to scale. Okay, so this looks to me like 10, and this side looks to me like 12. So the area of that rectangle would be 12 times 10, and that is 120. The line with the equation y is equal to minus 3 over 2x plus 39 intersects side AD at E and side AB at F. Determine the area of the pentagon BCDEF. Okay, so I'll draw that again. This time try to see if I can make it to scale. Not that it really matters, but what was it? 10, 15. Well, probably not going to be able to draw it to scale. That's okay. 15, 27, 10, and 20. And then I think it was, this would be the rectangle, right? Approximately. And then you've got this equation, y is equal to minus 3 over 2x plus 39, right? So that's going to be obviously somehow, somewhere, something like that. So then they're saying that it intersects at E. So here's E, I assume, and F, like that. Okay. So therefore, we have to figure out what E and F are, and then what are they trying? Oh, they want you to figure out the area of the pentagon. So that would be this guy right here. Okay. All right, that shouldn't be a problem because all we need to figure out is the length of the triangle, because the area of BCDEF would basically be the full area of the whole rectangle, which we calculated as 120, minus the area of that triangle, which would be 1/2 base times height. And as soon as we get base times height, we'll be able to figure that out. Okay, so we just have to figure out what are the coordinates of E and F. So E is when x is equal to 10, correct? Yeah. So we sub that into here. We will get y is equal to minus 3 over 2 times 10 plus 39. So that is minus 15 plus 39, so that is 24. So the coordinates of E are 10, 24. Okay, so E is right there, 24. So that means this side of that triangle is 9, correct? Yeah. I think I did that right. Okay, and then by the same kind of idea, we calculate F. F is when y is equal to 15. So 15 is equal to minus 3 over 2x plus 39. So that'd be 3 over 2x is equal to 24. So therefore x is equal to 16, I believe. All right, so that's right here, 16. So that means this part of that triangle is 6. So we got our 1/2 base times height. So the base is 6, the height is 9. So that means 120 minus, let's see, 3 times 9, 27. So that's going to be, I believe, 93. 93. The line with equation y is equal to mx plus b with m less than 0 intersects side AD at G and side AB at H. Determine all ordered pairs of integers mb with b less than 50 for which the area of triangle GAH is equal to minus 8 over m. So let's draw this again really quickly. We don't need to be too elaborate here because it's kind of the same story. So we got this triangle, and then we have this m is less than 0, so it's sort of the same kind of story. You know, you got this line here, y is equal to mx plus b, and they've told me that m is less than 0, so that's why I know that the line is going that way. And very similar to the previous question, the only difference is that now we have an m in this equation, but that's okay. So same thing, this was 10, this was 20, again not drawn on the scale, 15 and 27, correct? It's the same coordinates, but now we have this y equals mx plus b. Okay, so same thing. It's G and H. So this is now G, and this guy is H. Okay, so here we go. So for G, that is when x is equal to 10. So that means y is equal to, x is 10, so 10m plus b. Okay, well, that doesn't really give us much. It just tells us that the coordinates are 10 and 10m plus b. Previously we were able to get a number, but this time we have this m in there. But I guess we have to kind of work with that. Not a problem. It's just an extra variable. Okay, h, same thing. That happens when y is equal to 15. So that means that 15 is equal to mx plus b. Well, actually, is it mx plus b? Yeah, mx plus b. Then we have to solve for x, so that would be 15 minus b over m is x. So that means the coordinates of h would be 15 minus b over m, and then 15, right? Let me just see if I did that correctly. 10m plus b, 15 minus b over m, and 15. Okay, I think that's fine so far. So let's move forward. So let me just put a little box so we know. Okay, now what's the next step here? We've got what are we supposed to do here? Oh yeah, so the area of GAH is equal to minus 8 over m. So G, this is A, by the way, this corner. So triangle GAH, that area is 1/2 base times height. So the base, I guess the distance from A to H. So that's going to be, what is H? 15 minus b over m minus 10, correct? Yeah. And then the height is g minus a. So g, the y coordinate, is 10m plus b minus 15. Yeah. Okay. And then, of course, this side is this guy right here. They've told me it's minus 8 over m. And, okay, so I got a lot of algebra here, which sucks. Okay, let's do this. So we have 15 minus b minus 10m over m, and this is going to be nothing changed on this side, 10m plus b minus 15. Okay, so what are we trying to figure out here? Ordered pairs mb with b less than 50. Okay. All right, so we got this algebra to do here. So I think the m's cancel. So I'll multiply through by 2, so we get minus 16. That way we get rid of the half and the m. So this goes, and these two go. So then we're left with this minus 10m minus b plus 15. And then this 10m plus b minus 15. Okay, I see a little bit of similarity here. If you factor out a -1, you get 10m plus b minus 15. And then we have another 10m plus b minus 15. And that's minus 16. So 16 is basically 10m plus b minus 15 all squared. And if we take the square root, we'll get plus or minus 4 for 10m plus b minus 15. So that basically means we've got two equations. We've got the first one, which is 4 is equal to 10m plus b minus 15, and therefore 10m plus b would be 19. Yeah. And then the other guy, that's minus 4, is equal to 10m plus b minus 15. And then if we add 15 to both sides, it would be 11 is equal to 10m plus b. Okay, so we got two equations, and then I guess for both we have to figure out the ordered pairs of MB. 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 Okay, now before I proceed, let me just see this 10m plus b, if it jives. 10m plus b. Let me go back. Where is it? This one right here. You notice 10m plus b is here. So it's the y-coordinate of g. So if you notice, there's g right here. This is g, right? And the y-coordinate is here. Now, right there. Now, the y-coordinate is between 15 and 27. We know that for a fact. So it has to be between that 10m plus b has to be less than 27 and greater than 15, right? So let's use that to see if both of these are possible. 10m plus b, let me just put that in here somewhere. 10m plus b is between 27 and 15, right? So this would be fine because 19 falls in that range, but this would not be fine. So this, interesting. So then this is, I guess, inadmissible, or contradicts, or whatever term you want to use. So I guess we don't need to figure out for that guy. We just have to concentrate on this one. Okay, that's a good thing. So we're really just trying to figure out ordered pairs, and then of course there's one little tidbit that b is less than 50. I think that's just to help us out. Okay, so if b is less than 50, and are they integers? Hold on, let me just double check. Yes, they are ordered pairs of integers. Okay, so let's start with 49, because the 49 is the first integer less than 50 for b. Sub that into this equation right here, and when you do, you get m equal to minus 3. So you indeed get a ordered pair. And then continuing like that, if you actually isolate for b, you get 19 minus 10m is b, right? Oh, hold on. Yeah, 19 minus 10m. Or if you isolate for m, you get 19 minus b over 10 is equal to m. So that means that, what does it mean? It means something. I guess it's just trying to figure out an easier way of going through this instead of going 48, 47, 46, very time consuming. I think you have to go down by 10 in order to get an integer for m, because another way of doing it just by going values of m. So the next one would be minus 2, right? And minus 2 would give me 39, and then minus 1 would give me 29, and then what are the parameters for m? Is there a parameter for m? Yeah, m is less than 0. So then that's it. M is less than 0, so you can't choose 0. Yeah, so that's it. Those are the only 3 ordered pairs, and I think that's it. That pretty much completes the question. To determine the number of positive divisors of n, we take the exponents on the prime powers in the prime factorization of n. Add 1 to each of the exponents and multiply the resulting numbers together. For example, the prime factorization of 280 is 2 to the power of 3 times 5 to the power of 1 times 7 to the power of 1. And so 280 has 3 plus 1 times 1 plus 1 times 1 plus 1, which equals 16 positive divisors. How many ordered pairs of positive integers AB are there for which AB equals 400 and 1 is less than A is less than or equal to B? Okay. Let's see. So 400, we have to first do the prime factorization of that. And that would be 2 times 2 times 2 times 2 times 5 times 5. So that is 2 to the power of 4 times 5 to the power of 2. Right? So using their, system, which is a system I already know, the number of divisors would be, take that 4, add 1, take that 2, add 1, and then multiply this. So it'll be 5 times 3. So 15 divisors of this number. Okay. What are they asking? How many ordered pairs AB? Interesting question. How many ordered pairs AB? Okay. Wouldn't it be 15? Ah, but you've got this parameter. Okay, I got it. I see. I understand what they're doing. Because otherwise it would be too straightforward. They've given you a condition. That's why it's less than 15. That A has to be greater than 1, and it has to be less than or equal to B. Okay. And this is, of course, A times B. All right. So the first thing I'm going to do is list all these 15 divisors. So we got 1, 2, 4, 5, 8, 10, 16, 20, 25, 40, and then 50, 80, 100, 200, and 400. Okay. So in order to get, I guess, satisfy that inequality, we've got to figure out how do we get A times B to equal 400 and keep this condition. And then, of course, these guys will help us. Okay, we can't use 1 because A has to be greater than 1, so that one's out. But we can use 2, the next one. And if we do, the B would be 200. So that's pretty straightforward. We can use 4, and if we do, the B would be 100. And let's see, we can use 5. If we do, the B would be 80. All right? And if we use 8, the B would be 50. The 10, if we use that, the B would be 40. The 16, if we use that for A, the B would be 25. And the 20, if we use that, the B would also be 20, right? And then after that, like for example, if we used A to be 25, the B would be 16. And this would fall apart, meaning like this one here, it would fail this inequality because A has to be less than or equal to B. So these are the only ones that satisfy the A is less than or equal to. So that's 1, 2, 3, 4, 5, 6, 7. So 7 is the answer to that question. Determine the number of ordered triples of positive integers PQR for which PQR is 270000. Okay. So PQR is 270000. Okay, so we gotta do the prime factorization of this. So that's gonna be 2 to the power of 4, 3 to the power of 3, and 5 to the power of 4. Okay, so what are we doing here? Determine the number of ordered triples of positive integers PQR for which PQR is equal to. Okay. I think we just have to kind of think about this one at a time with regard to each of these guys. So for example, for P, Q, and R, if we look at the threes, these guys, you can have the 3 kind of distributed like that. Or you can have the 3s like 1 is 3 and the other is 3 to the power of 2. And there's going to be about 6 of those guys, right? 3 to the power of 2, like that. 3 to the power of 2, like that. Any other ways of doing this? I think so. Should be. Oh, you put all 3, the 3 to the power of 3 in one of the P, Q, or R. Yeah. And I think that exhausts the ways of doing it, of allocating the 3s to P, Q, and R. Yeah. So that is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 ways of allocating the powers of 3. Okay, so we'll hang on to that 10 for now, and I guess we'll have to use it once we get the answers to the other ones. So P, Q, and R. Now let's try to allocate the 2. This guy, the 2 to the power of 4. Okay, so that's going to be, let me think about this for a second. The first way, I think, is just the 2 to the power of 4, just putting it in one of the 3, like that. And then the other way is to divide it, the 2 to the power of 3 and 2 to the power of 1, like that. And that is going to give me a total of 6 ways. I mean, you can write it out, but I'm sure you know how. It's very similar to writing these guys out. These guys. And then the other way is mixing it up into 2 to the power of 2 and 2 to the power of 2. And there's 3 ways of doing that. And the other way is to have 2 to the power of 2, 2 to the power of 1, and 2 to the power of 1. And there's 3 ways of arranging that. So they have 1, 2, 3, 9, plus 6, 15. So there's 15 ways of doing that. And for the 5, it would be pretty much identical to how we did the 2s. So you'd have another 15 ways of allocating the 5s. So the total number of ways of getting P or Q or R, like those ordered triples, it would be that 10 times this 15 times this 15. And that is 2250. Determine the number of ordered triples of positive integers x, y, and z for which x, y, z equals 270000 and 1 is less than x, less than or equal to y, less than or equal to z. So the question is identical to the previous one, but they've got this extra condition, and that extra condition will narrow things down. Remember, before the answer was 2250, but obviously this condition will narrow it down to a lower number. Okay, so here we go. Where do we begin, actually? Well, let's work with this inequality, since that is the main thing that they gave us. So x could either be equal to y, and then we have z separate, or y could be equal to z, and then we have x separate, or x could be equal to z, and if x is equal to z, I think you would have all 3 equal. Yeah, then you equal y, something like that. Okay. Let me just see here. If y is equal to z, x could be less than, yeah, okay. All right, so if we have the first one, x, y times z is equal to 270000, then again, using this, it will be x squared z is equal to, and what was the prime factorization again? 2 to the power of 4, 3 to the power of 3, 5 to the power of 4, right? So x squared, I got it. So this x squared, I'll just write it here. It's a perfect square, right? Perfect square. And it would therefore be a divisor of this 2 to the power of 4, 3 to the power of 3, 5 to the power of 4. You got it? So that is going to help us. Now, how it's a divisor, that we have to figure out. It's going to be of the form 2 to the power of u, 3 to the power of v, 5 to the power of w. but these have to be even numbers. That's the only way you can get a perfect square. So u could be either 0, 2, or 4. Keeping that in mind, v can be either 0 or 2, or w can be 0, 2, or 4. And therefore, there's 3 options there, there's 2 options there, and there's 3 options there. So we have 3 times 2 times 3, which I believe is 18 perfect square divisors. Perfect square divisors, right? If two factors are equal. Yeah, if two factors are equal. So I think since this 18 we figured out for this guy, so there'd be another 18 here and another 18 here, so a total of 54, right? 18 times 3. Yeah. Okay, so that's actually pretty good. So that means with this 2250, that's the total, and we've got 54 cases that kind of fit this category. Okay, so now what we're going to do is we're going to look at a scenario where x, y, and z are all different. So from the 2250 total, we can subtract the 54. So we know that is 2196, and that would be a potential number of cases that match that, since the 54 match these guys up here, these guys. But the 2196 I think overcounts by a lot, because you can have, like, if you have x, y, z, you can have 6 iterations. Like, for example, whatever, like let's say you have 2, 3, and 5. There's 6 ways of making that. It'd be like 2, 3, 5, 2, 5, 3, 3, 2, 5, 3, 5, 2, 5, 2, 3, and 5, 3, 2. You see what I mean? So that 2196 overcounts by a factor of 6. We have to divide by 6 to get 366. So the 366 is something we need to narrow it down to. So far, if we go back to that criteria, it looks like we have 366 where they're all distinct, which is what this is, plus an 18, like we calculated here, where exactly 2 are equal. Okay, so that's pretty good, and that total I think is 384. All right, are we done, or we have some other criteria here? I think we have one other criteria that, look at this carefully, x has to be greater than 1. Yeah. So let me put that in inequality again. X is greater than 1, and then less than or equal to y, less than or equal to z. So since x is greater than 1, and then x, y, z was that big long thing, 2 to the power of 4, 3 to the power of 3, 5 to the power of 4, we have to eliminate all the ones where x is 1. So first let x equal to 1, and that would give me, in this equation, yz is equal to 2 to the power of 4, 3 to the power of 3, 5 to the power of 4. And in terms of the number of divisors, it would be 4 plus 1 times 3 plus 1 times 4 plus 1, which is 5 times 5 times 4, right? So that's 100. So if 100 of those guys, yeah. But y has to be less than or equal to z. So there'd be 50 factor pairs. Yeah, this is 100 divisors, right? Yeah, there'd be 50 factor pairs with y less than or equal to z. So there'll be 50 ordered triples. Yeah, I got it. So 50 ordered triples with x equal to 1. And those are the ones we have to subtract from this. So therefore, we can put that in here. Let me just put a little box. And therefore, the total number of ordered triples that satisfy all our conditions with 1 less than x less than y, y less than or equal to z would be this 384 up here minus this 50, and that would give me 334 as the final answer.